Welcome to Julia for Talented Amateurs, where I make wholesome Julia tutorials for talented amateurs everywhere. I'm your host, the Dabbling Doggo.
I dabble.
Last week, we learned what a computer is and what a programming language does. After that, we used Juno for the first time and learned some basic math operations. Today, I will discuss two separate topics. In the first half of this tutorial, I will discuss the relationship between variables, expressions, and memory. In the second half, I will introduce the concept of data types, or simply types, and share some examples of several different types used in Julia. For the next several tutorials, we will be spending most of our time in Atom, so go ahead and double-click on that Atom shortcut to launch Atom. Adjust the sidebar so that the right panel takes up about 1/3 of your screen. Click anywhere in the REPL panel and hit Enter to start Julia. You know what variables are, right? You've seen them in math class. When you write x equals 1, y equals 2, z equals x plus y, x, y, and z are called variables. In math, they are placeholders for values that can change. Initially, x and y have the values 1 and 2, so z is the same as 1 plus 2, or 3. If you change x from 1 to 2, then the value z changes as well, because x plus y is now 2 plus 2, or 4. Let's try this in Julia to see what happens. X equals 1, y equals 2, z equals x plus y. So far so good, right? It's just like we expected. You can see the values of x, y, and z by simply typing in x, y, z. You can also see them listed in the workspace panel on the right side of your screen. Now let's try changing x from 1 to 2 to see what happens. Now type in x, y, z. What happened? Why does z still equal 3? Didn't we tell Julia that z equals x plus y? X plus y should now be 2 plus 2, so why didn't z update?
I can't take it anymore!
Congratulations! You have reached the exact moment when many people give up on programming and go back to using their calculators or spreadsheet apps. That modulo thing last week may have been a little weird, but this is like next level weird. However, don't despair, gentle amateurs. Let's take a step back and try to figure out what's going on.
You can do it!
What you just witnessed has nothing to do with Julia. This is actually how your computer works. But you say, I thought computers were smart. Your computer is neither smart nor stupid. It just does what you tell it to do, and nothing more. It's important to recognize that your computer is not doing math. It's doing what it was designed to do. It's doing computing, which resembles math, but is different than math. In math, a variable is a placeholder for varying expressions or quantities. In computing, a variable is a storage location which contains some value. Let me repeat that. In computing, a variable is a storage location. Wait, what? This is, of course, very different than math. When you initially typed in x equals 1, y equals 2, z equals x plus y, what you really did was set up 3 different storage locations in your computer's memory, and you labeled them x, y, and z. And then you told your computer to store the values 1, 2, and 3, respectively, in those locations. In the case of z, your computer is only storing the value 3 and not the expression x plus y. If you want to change the value stored in location z, you need to tell your computer to change the value in location z. Now, the value of z has updated to 4 because you told it to update. In computing, a variable is often used to refer to both the storage location as well as the value contained in that storage location, which is why it can get confusing. However, it's important to understand that these are two different things. In the case of the storage location, the terminology used is that the variable name is quote-unquote bound to that storage location. Once you've labeled that storage location, you cannot change it. However, the value stored in that storage location is allowed to change as many times as you like. In general, setting up a new variable follows this generic format. The variable name is on the left-hand side, followed by an equal sign, followed by an expression on the right-hand side. Here, the equal sign does not mean equals to, like in math. In computing, the equal sign means is bound to. Now that we understand conceptually of the relationship between variables, expressions, and memory, let's take a look at some examples. Here's another example of how computing is different than math. Try to enter the following. You get an error. Why? X plus y equals 2 is allowed in math, but not in computing. X plus y equals 2 is read by Julia as the variable x plus y is bound to a storage location that contains the value 2. There's no problem with the value 2 on the right-hand side, but Julia doesn't know what to do with x plus y on the left-hand side. Is x plus y a variable name? Is x plus y an expression? It's ambiguous to Julia, so it throws out an error message. Now try typing in the following. Y equals 2 minus x is the same thing as x plus y equals 2 in math. However, this is allowed in computing, because now it's clear to Julia what you mean. Y equals 2 minus x is read the variable y is bound to a storage location that contains the value of the expression 2 minus x. Also start getting into the habit of looking at the workspace. Here's another example of how computing is different than math, but the other way around. This example is allowed in computing, but not allowed in math. Note that x equals x plus 1 is not allowed in math. In math, this would be like saying 1 is equal to 2, which is nonsense. So why did it work in your computer? Here's the sequence of steps that Julia used after you hit enter following x equals x plus 1. Step 1. Evaluate the expression on the right-hand side, x plus 1. Step 2. Take the current value stored in location x, which is 1, and then add 1 to it, and return the value 2. Step 3. Now take the value 2 and place it into location x. This is very different than math. X equals x plus 1 is often used by programmers as a number counter. It's used so often that it has its own shorthand form. This notation x plus equals 1 is the same as x equals x plus 1. It's just a shorthand form of it. Now look at the workspace for x. X equals 2, right? Hit the up arrow and hit enter. Now x equals 3. Up arrow, enter, now it's 4. Up arrow, enter, now it's 5. You can see that it's counting up, which is why programmers use it as a number counter. Here's a practical example of how variables can be used. So length equals 2, width equals 3. Now you can use the variables length and width like any other operand. Area equals length times width. You may remember that from geometry class as the area of a rectangle. Look at your workspace on the right side and look for length, width, and area. As you can see, the variable names are on the left, and the values stored in these locations are on the right. The workspace panel keeps track of all of the variable names and their current values in your active Julia session. Julia uses the variable named ANS, or answer, to keep track of the value of the last evaluated expression. In our case, ANS is a storage location that contains the value 6. You can use ANS like any other variable. For example, ANS times 2 is the same as 6 times 2, or 12. Notice that ANS has now changed to 12. Use the up arrow, hit enter, and now ANS equals 24. Note that variable names are case sensitive, so lowercase x equals 1, uppercase x equals 2, lowercase x plus uppercase x will give you 3. Although this is allowed in Julia, this can get very confusing. As a best practice, you should keep your variable names all lowercase. Variables also can be used with comparison operators. So in this case, a equals 1, b equals 2, c equals 3. Say, is a greater than b? And that's false because 1 is not greater than 2. In this case, is a less than b? And that's true. Here's another example. And this is false because this is the same thing as are both sides true in the case of true and false. Of course, that's false. And this is true because this is read as either side true. And this is the same as is either side true here. And of course, one side is true. Now look at the workspace. Notice that ANS now contains true. When naming variables, the convention is to use a single, easy-to-remember word, starting with a lowercase letter. There are some words that you cannot use as variable names because they are so-called reserved words. For example, begin and end. If you try to use begin as a variable name, you'll get an error. If you try to use end as a variable name, you'll get an error. We'll discuss more reserved words throughout this tutorial series. Julia also has a built-in function called varinfo, short for variable info. Varinfo shows you a list of all your variables, how much memory it's taking up, and their data type. We will discuss data types in the very next section. In Julia, every value of an expression has a type. Type is short for data type, and Julia recognizes many different data types. The ones that I will be covering today are numbers, characters, strings, symbols, and Booleans. Numbers include integers, floating point numbers, rational numbers, and irrational numbers. All of these types fall under the umbrella type called any. Here are some examples of integers. int64 is short for 64-bit integer. Type of is a built-in function that identifies data types. You can use the up arrow instead of retyping. So 0 is another example of an integer. 12 is an integer. Here are some examples of floating point numbers. So for example, negative 1.2 gives you float 64. Float 64 is short for 64-bit floating point number. So 0.0 is another float. .14 is another example of a floating point number. This one's a little surprising. NaN, that stands for not a number. It's also of type float. Before we go on, just a side note about floating point numbers. Enter 0.1 plus 0.2, and before you hit enter, what do you think you'll get? You should get 0.3, right? Now hit enter. What just happened? Is this another bug? Is your computer broken? Now check. Now this is 0.1 plus 0.2 equal in value to 0.3? Now this should be true, right? Despite their appearances, floating point numbers are not technically precise numbers. The reason they exist is because computers do all of their calculations in binary, or base 2, so the only numbers your computer knows are multiples of 2. Going up from the number 1 is 1, 2, 4, 8, 16, etc. And going down from 1 is 1, 1/2, 1/4, 1/8, 1/16, etc. When you enter in 0.1, your computer doesn't know the value of 0.1. 0.1 is the same as 1/10, and as you can see, there's no 1/10 in base 2. Your computer only knows that 1/10 is some value between 1/8 and 1/16. Or somewhere between 0.125 and 0.0625. Since there's no way to represent 0.1 in base 2, your computer comes up with a scientific approximation for 0.1 in base 2. You can actually see the bit string in Julia by typing in bitstring. So the bit string for 0 is all zeros, as you might expect. On my screen, it's a 64-digit number because I'm using a 64-bit computer. If you hit the up arrow and change the 0 to a 1, you can see it's all zeros except for that very lonely 1 at the end. Now change that 1 to 0.1. Now look how crazy that looks. This is what your computer sees. So if you change it to 0.2, this is what your computer is working with when you're trying to add 0.1 to 0.2. Now change that to 0.3, and this is what 0.3 looks like to your computer. So when you tell your computer add 0.1 to 0.2, it's trying to add those two numbers and trying to get to this 0.3, which it's never going to do. What you don't see is you're only seeing 64 digits. These are actually repeating numbers, so they go on forever. Since 0.1 and 0.2 are repeating numbers in base 2, your computer converts 0.1 and 0.2 into 64-bit base 2 approximations, then adds them together, then converts the resulting approximation back into base 10. This is where all those extra zeros come from in 0.3, 000, etc. This is not a bug. Believe it or not, this is just how your computer works. Here are some examples of rational numbers. -1//2. Note there's a double slash there. That stands for -1/2. You may recognize rational numbers by their more common name, fractions. Here's another example, 0//3. It's a rational number. And one last example, 5//2. It's the same thing as 5/2. It's a rational number. Julia allows the use of rational numbers as operands. So this is the same thing as 1/2 plus 1/4, which gives you 3/4. Here's an example of a very famous irrational number. So pi is a built-in constant in Julia. It's a type of, it's an irrational number. When using numbers in Julia, there are acceptable ways to enter numbers and some unacceptable ways. The following are some acceptable ways to enter numbers in Julia. So that's 10 to the 6th power, or 1 million. You can just type in 1,000,000, and that's 1 million. Or you can type in 1_000_000, and that's an acceptable way to write 1 million. So just to check, you can type in and it's true because all of these equal 1 million. 1 is how you do 100%, 1//0. This is an infinite rational number. So these are all acceptable. The following are not acceptable ways to enter numbers in Julia. 1,000,000,000. You get something not what you were expecting. That's not what we want. So you can't use commas to separate your large numbers. Here's another example, $1 million. You get a syntax error because currency signs are not allowed. 100%, you can't enter that because Julia thinks you're trying to do the remainder operation and is waiting for you to enter another number. 0//0, and you get an error because 0 divided by 0 is an undefined number. Julia also has some useful built-in functions when dealing with numbers. Printline and type of are examples of built-in functions. Built-in functions are mini programs that come included with Julia for your convenience. The following are some useful built-in math functions. Square root of 4 will give you the square root of 4. Cube root of 8 will give you the cube root of 8, which is 2. Sometimes you want to convert numbers from one type to another. So what this does is convert the 3.0, which is type float, into an integer. So you can see the result is 3 with no decimal points after it. Is even checks to see if your number is even, which in this case is not. Is odd checks to see if your number is odd. And of course that one's true. REM stands for remainder. This is the remainder function. It gives you the remainder of 5 divided by 2. The remainder is 1. It is the same thing as that we learned last week for 5 modulo 2, which gives you 1. Sometimes you want to round numbers. So in this example, if you just wanted 2 digits, we'll give you 3.14. Sometimes you want to round up or round down, and this is how you do it. Round up, we'll give you 3.6. You hit the up arrow to bring it back up, change the up to down, we'll give you 3.5. Before leaving numbers, just a note about the equal sign. When using the equal sign in Julia, it's important to distinguish between a single, double, or triple equal signs, since they all mean different things. I equals j is the variable assignment operator. In other words, bind the variable named I to a location containing the value of j. This is the equality test. In other words, is I equal in value to j, as we discussed in the last tutorial? This is called the identity test. Note there are 3 equal sign here. And this is read, is I identical in value and type to j? This is new, so let's take a look at an example. So in this initial setup, a equals 3, which is an integer, b equals 3.0, which is a floating point number. So if we do the equality test, is a equal in value to b, the answer is true. But if we do the identity test, which is 3 equal sign, the answer is false. Now a and b are both 3, but a is type integer 64 and b is type float 64. So they may be equal in value, but they're not the same type, thus not identical. Here are some examples of characters. So this lowercase a is type char, short for character, and note the use of the apostrophes and not quotation marks. There's another example of a character, the hashtag. You can use Unicode characters while programming in Julia. Open up your browser and do a Google search. Do a Google search for Julia Unicode. And go to that Unicode input, the Julia language, and bookmark this page. The tab completion sequence column shows you all of the keystrokes that you can use to generate the Unicode on your screen. Let's take a look at some examples. Type in backslash alpha and tab will give you the Greek letter alpha. If you do backslash beta tab, will give you the Greek letter beta. And if you do backslash delta tab, will give you the Greek letter delta. You can also do uppercase Greek letters. Tab will give you the uppercase delta. Now you can also do the Greek letter pi, tab, enter, and it's set to the value of pi. It's the same as pi. You can also type in Euler, tab, and this will give you Euler's constant. Now when we did 5 divided by 2, you got 2.5. And what I didn't tell you is that this operator will always give you a floating point number. So even if you do 4 divided by 2, which should give you just an integer of 2, it returns a 2.0, which is type float. And that's because the slash operator, this division operator, will always give you a floating point number as a result. If you just want an integer value, you can do div 5, 2. This will give you just the integer portion of that division. You can also do 5 backslash div tab 2. And that's the same thing, but you get to use the classic division sign that you saw from elementary school. Backslash square root tab will give you the square root sign. So this will give you the square root of 4, which is the same thing as the square root function of 4. And same thing with cube root. Backslash cube root tab and say cube root of 8 will give you 2. That's the same thing as cube root of 8. Now here's a fun one. So this backslash approx tab will give you approximately equal to. So this, let's see what happens when we hit enter. So now this is true. You can also do superscripts, e equals MC, and do a backslash, caret, 2, tab. We'll give you a superscript 2. And you get e equals MC squared. You can do subscripts, so H, backslash, underscore 2, tab. We'll give you a subscript 2, O equals water. You can use these Unicode characters as variables. So alpha equals 1, beta equals 2. Now you can do alpha tab plus beta tab, and that gets you 3. You can even use emojis. Phone tab will give you the phone emoji. Tab will give you the snowman emoji. So some Unicode characters do not work in the REPL, but they all work in the actual text editor, which we'll see later in the tutorial series. Here's a useful built-in function for characters. This function will give you the ASCII character, so if you enter in a number between 1 and 127, it'll give you the ASCII equivalent. So for example, 65 will give you the uppercase A in ASCII. This is how you enter in a multi-line comment. You do the hashtag equals, and then you can type in whatever you want. So the dollar sign is a special character, the percent sign is a special character, the hashtag, this is used for single line comments, the exclamation mark, the backslash, and then in order to close out a multi-line comment, you type in equals hashtag, and that will close it out. This allows you to write in comments when you're writing long blocks of code. So all of those characters have special purposes in Julia, so be careful when you use them. A string is a sequence of characters. This is how you print a string. So here's one you see a lot. Hello world. Type of S1 is of type string. You do print line of S1. Seen that before. And here it prints without the ln. See, this is the difference. There's no extra line after hello world. That's the only difference. This is how you print a string with quotation marks. Use triple quotes and triple quotes to close it. So use the back arrow to get back into it. This is an quote unquote interesting tutorial. And when you hit enter, you're going to see the backslash characters. But if you do print line S2, it prints exactly how you want it to print with the quotation marks. Here's some common special characters that you can use within a string. Backslash n is for a new line. Backslash n and no space. Backslash n, no space. Will give you 3 separate lines because the backslash n is like a return. The backslash t is for tab. So if you type in 1 backslash t, 2 backslash t, 3 backslash t, 4 backslash t, 5, you get 1, 2, 3, 4, 5 separated by tabs. This is how you repeat a string. Leave a space after the snowman. The snow person, if you want to repeat this emoji, all you have to do is snow person times snow person, and you'll get 2. If you want more than that, you can use the caret like an exponent, and this will repeat it 3 times. Or hit the up arrow and change that 3 to 1,000, and you can fill your screen with them. You can also use a built-in function called repeat. and just tell it how many times you want it to repeat. Or you can just change it to whatever number you like and fill your screen with it. Here's how you concatenate a string. How much would S4 equals just a blank space so if you want to concatenate S3, S4, S5, you can do that by using the multiplication sign. Or alternatively, you could use a built-in string function. It does the same thing. Now look at the workspace for all of the S variables. Note that the workspace also lists the data types as well. So if you hover over this red column, you can see that the S is type string, but if you go into these numbers, it'll say this is int64, and this one is a float64. So it's a very useful panel. Here's how you can interpolate a string. Let's take a look at this menu from the Krusty Krab. The Krabby Patty is $1.50. Coral Bits, $1.25. Seafoam Soda, $1.25. The Krabby Meal is $3.50. And the place is the Krusty Krab. Now there are two methods you can use for string interpolation. Method 1 uses the $sign to interpolate the variable within the quotation marks. So in this example, print line, I am eating lunch at the $sign variable place. So you can see what it did there. It took Krusty Krab and inserted it where the $sign is. Here's another example. $sign parentheses. Now you can put an expression in here. So you can see interpolation is not just for text, but you can actually put an expression and have it do a calculation within the string. So this is one way to do it. You use the $sign to interpolate the variable within the quotation marks. Not only can you do it for text, you can do it for numbers, you can do calculations. Method 2 is to use comma separations outside of the quotation marks. So these are going to be the exact same examples, except I'm going to use commas instead of a $sign. And then get out of the quotes, comma, place, comma, quotes for a period. You see you get the same result. It's a little different in terms of how you enter it, but you can also do it by using commas. Now get outside of the quotes, put a comma. Comma, and then enter more quotes to close out the sentence. So you get the same result as when you use the $signs, except you have to get outside of the quotes, put a comma, put in what you're trying to concatenate, and then get back into the quotes. Get outside of the quotes, comma, comma, quotes. So there you go. You have two different ways you can do the same thing. Like many things in Julia, there are multiple ways to do the same thing. A lot of it will come down to what's more efficient for you at the time. There's no currency formatting in Julia, so you cannot use US dollars, euros, or yens for calculation. For example, if you type in $100, you'll get a syntax error. Also, if you try to print $100, you'll get an error because we just saw the $ is used for a string interpolation. If you want to display a currency for some reason, you can still do it. So in the case of the US dollar, do a $$ and that will print $100. And in the case of euro, \euro tab 100. That'll give you 100 euro. \yen for yen. This will give you 100 yen. Now remember, these are all strings, so you cannot use them for calculations. Here's how you can get a string input from a user. Type in print, not print line, just print. Enter some text. Space. Now put a semicolon and read line. Not read ln, but read line, L-I-N-E. That semicolon, what that does, it allows you to enter multiple lines of code. I'm going to type in hello world. But you can type in whatever you like. Now look at the workspace for the variable text. You can see it says hello world. If you type in text, it'll give you hello world. If you type in print line text, it'll print it out for you. And if you say, what is the type of the variable text? It says it is of type string. Now here's how you could convert a string into a number. Similar to above, say print, not print line, but print. Enter a number, semicolon, read line. Now I'm going to type in 1, 2, 3, but you type in whatever number you like. And enter in num equals parse, P-A-R-S-E, int 64, comma, text. Now, what just happened was, when you entered in 1, 2, 3, Julia read it as a string. And what this parse function does, it converts the string into whatever data type you tell it to, in this case, integers. Type of text is a string. Type of num is an integer. So when you try to do calculations using strings, you get an error. But num plus num, you can do calculations with integers. Now sometimes you want to go the other way around. You want to convert a number into a string. So in this case, if integer equals 1, 2, 3, say the string version of the num is equal to string. You can use the string function to convert a number into a string. Type of, this was originally an integer 64. And you can see you've converted it into a string. So if you do I plus I, that's okay. But if you do snum plus snum, you get an error because they're both strings. In Julia, symbols are human-readable unique identifiers. Using a colon immediately followed by a variable name will create a data type called symbol. See, there's data type symbol. We'll see a more detailed example of how a symbol is used in a few minutes. We introduced Booleans in the last tutorial, but I didn't tell you that Booleans have their own data type. So you can see it's type bool, and there are only 2 of them, true and false. And finally, there's actually a data type called any. If Julia can't figure out a data type, it uses the data type any as the default data type. To end this tutorial on a light note, here's a fun and frivolous example of how symbols and bools may be used in Julia. Because what's the point of learning how to code if you can't have a little fun along the way? You can print strings in different colors using a built-in function called printStyled. We'll use S1 since it's already set up. If you type in printStyled S1, comma, bold equals true, so that's a Boolean. Color equals colon red, so that's a symbol, that color. If you hit enter, you'll see hello world comes out in red. Now the available colors are white, which is the default colors. You can use the RGB colors, which are red, green, and blue. Or you can use the CMYK colors, which are for printers. It's cyan, magenta, yellow, black. You can use begin and end as a way to enter multiple lines of code in the REPL, and this is called a code block. So we're going to use this code block to come up with something. Begin, enter, tab. PrintStyled, quotes. Now within the quotes do space, 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 3 spaces, backslash pi, tab, and then get out of the quotes, comma, bold equals true, comma, color equals colon, green. Enter. Print line, and that will just give you a new line. Print styled, parentheses, quote, space, space, so 2 spaces, backslash pi, tab, space. Get out of the quotes, comma, bold equals true, comma, color equals colon red. Enter. And then finally, print styled, parentheses, quotes, backslash pi, tab, get out of the quotes, comma, bold equals true, color equals magenta. Enter, backspace, end. Today, we learned about the relationship between variables, expressions, and memory, as well as viewing several different data types. For reinforcement, we saw a lot of different examples. Next week, I'll show you the different data structures used in Julia. If you enjoyed this video and you feel like you learned something new, please give it a thumbs up. For more wholesome Julia tutorials, please be sure to subscribe and hit that bell. If you have any questions, please post them in the comments below or send me an email at julia4ta@gmail.com. I will be changing my upload schedule starting in October. I will begin uploading tutorials on Sundays and uploading the Q&A sessions on the following Saturday. I'm hoping to upload the next tutorial on Sunday, October 4th, so stay tuned. Please feel free to spread the word by sharing this video, since I'm sure you'll all agree that this is the finest tutorial on all of YouTube.
Worst tutorial ever.